still we need to download the MPI. That's gonna work. You can try to finish all today or make sense.
下载，这我是，
他还在那边那个了。
Maybe send and receive. Will you try it? Okay, send and receive, and then the last part is actually this. Not this one, you don't try it. Gone through, maybe your book has gone through question 4. Is that true?
Yes.
Not true, right? Okay, so question 5. It's the last one. Meanwhile, we have to download this first. Wait to assist and install it because it's not installed on the PC when you go up. Yes, we download. Make sure you don't allow the download only the first one. Allow only the download both. We will install each one of them in order. Okay, at the same time, we might want to go to environment. Click OK. Click OK. Okay. And once that's done, and also the library installed, open up your Visual Studio. Okay, if you don't have the great one, if you have, just open it up. I suggest that you save a copy. I saved my copy before. Open up your copy, your own copy.
是这五个字的是
不懂。
If you download the Google, I think it takes a while because you have to scan for a while.
Yes, 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 yes.
Create a new one. Just, do like usual.
Yes.
Console app and then continue. Because I want to use my own copies, so I'm going to copy into your name of your PC, source, Windows, PC, content, all this.
那里有个
但是 然后这个地方是
然后拿什么？
对，
要拿什么？
copy 这个去那个 environment variable。
Visual Studio. Source. Okay, in my case, I want to open up here, so just double click. Okay, if you open your previous project, you don't have to do this, because if you use your old project, you already have all this in place, right? If you are using, if you create a new one, then you have to add all this. That means you have to repeat what you have done before. You should have all the libraries installed. The path is installed. Path is installed. And also the name of the library that is there. My one is already there because I used my previous project. Okay, so we are going to do scatter gather today. And we just get into
有那个 particular 的发的名字，
那是 computing。
this one. Okay, and then copy this. And paste it here. Paste it here. Okay, and this name, going to call it name, call it scatter gather. And up here, we are all this, so cut this and put it right on top. Got that. I don't want to use this, I use other screen. Time is already there in my case, I don't need it, it's already there. This one is already there, it's already there, so average, you cannot the average. Okay, we do it on a single thread. It's very simple. Everybody one thread compute the whole thing. But if we want to use parallel computing, in our case here, we can also distribute it to different PC. But here we do it on one PC first. Assuming that your processor has multiple thread, multiple core, then you can have zero. Okay. Zero is going to scatter. So this thread zero will have data. So data 1, data 2, data 3, data 4. Okay, so this data will be processed by the same program. Let's say, for example, in this case here, you got an image, for example, right? And then you want to compress. You want to compress this image to a smaller data, right? But this image, when you do the compression algorithm is the same. There's no difference in the compression algorithm. Okay? The program is the same. But we're going to allow these processors to compress individual part of the image. So this is the whole image. And let's say we got 4 process. Let's say process 0, process 1, it's process 0, process 1, process 2, process 2. Okay? And suppose this data is D1, D2, D3, D4. Okay? So the image, you break it down. So this one is domain decomposition, the one that I mentioned in the past, right? Here, you can decompose by domain. Okay? So this is the domain of our data, and we split them into 4 equal parts. Okay, these are image, one part of the image, and you want to compress, you use the same algorithm. Okay, so this program is going to run the same algorithm run by the rest of the processes. Okay, and this data needs to be scattered. Okay, so this is going to process D1, which is this part, this D2, this D3, this D4. Okay, so one compress, the data is going to be smaller. Okay, going to be smaller. And somehow you want to, after you compress it, you want to save it, right? You want to save it into the file, for example. Now you have to get that. So this is scatter to all the processors so that they can do the processing. And once they are done, it is going to gather here. Okay, we're going to choose one process. Most probably is P0 again. And this is going to gather back into this. So maybe I should do something like this. So it's going to process it into, let's say, A1. This is going to process it into A2. This is going to process it into A3. Okay, this is going to process it to A4. Okay. So when you get you don't send a D1, actually you send the process data, which is A1, A2, A3, A4. So here is going to be A1, A2, A3, A4. And then this is the raw data, this is the process data, which is, in our case, is a compressed image. It will be smaller than this. Now P0 can combine them together and write into the file. Okay. So what is the advantage of this? The advantage is you can run in parallel this compression. Okay. If you do it by P0 alone, then P0 have to go through in sequence. Compress this one first, after finish, compress this one, compress this one. So it takes time to compress. Now if you scatter this data and done by all these processes in parallel, then you can take you can improve the performance maximum in this case 4 times faster. Okay? assuming that the data is not shared. So by default, the best performance that you can get is 4 times. Okay. Now if you split it into 8, then the best performance that you can get is 8 times. Okay. That is discounting the scattering time and also time to actually gather. Okay. So we assume that the scatter and gather is fast, then you get close to the number of processes that we start. Okay. In our case here, we are not doing image processing. Ours one is much simpler. The data that we put down here is actually random data. So we create random data. Okay? These are all random data. Right? And then you will do the processing, and the processing is not image compression. What we did here is actually taking the average. Okay, you compute the average value of D1. Okay, that means you process it, you find what is the average, and then you gather. Okay, after you gather already, this P0 is going to find the average again of this. You have to find the average. Okay, so finally you print out the average. Okay, so you can do averaging using one thread also. If you use one thread, then this thread is going to average out these numbers from D1 to D4, and has to take longer time to do it, right? Because it has to do it slow. Now, if you use parallel computing, you can scatter it, and all of them will be running the same program to find the average. Okay, once you get the average, and then combine them. Okay, so this one is partial average. Now you take the average of all this, basically the same as finding the average of all this, right? So that is our objective. Now, this program here, it finds the average is already using scatter gather, but you can write another program because you want to find out whether the performance is good or not. You can run the program using only one process. Let's say process A. Okay, it's going to find average. Okay, when you find average, you go and compare whether this average is the same. If the same image is correct. But anyway, this program given to you is already correct. Okay? If you don't change the program, it should be correct. Alright? So that is our objective for this. Is just to demonstrate using a simple example, finding the average. Okay? But then if you do use this in your image compression, you should be able to get performance gain as well. Okay? This one is image processing. This one is much simpler. Okay. Now you see some weird things here. Okay, what are these? I'm going to explain that. Because I already got it up there. Yeah, I've written the code here. Actually, I wrote this yesterday when I was doing the practical with the other group. Okay, I'm not going to type all over again. This to explain the first few lines in here. I want to explain this concept, what it is. Alright, in order to explain that, take note of these two. Remember, I want to explain this later. Now it's time to explain about these two later. So what are these two? Okay, these are the input arguments that you pass in through your program. I will demonstrate to you how you pass it in. When you pass it in, you can pass it like this. Let's say, for example, this is your program. say my program is P6, right? P6.exe. And then I pass in some value, let's say 1, 2, 3. Passing these 3 values, right? Okay, so how does my program go and use this data that is passed into my program through my command line? Okay, so I write the name and I pass in the values inside that. Here I pass value. Actually, you can pass many more things. You can pass in string, let's say hello world. Hello world there. Okay, so basically I pass how many? I pass 1, 2, 3, 4, 5. Now how do you know there are 5 there? The reason is because I put space here. Okay, there's a space here, 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 but there's no space in between them. So this is considered as one piece. There's no space between. Let's say if I put 12 here, right? So this is considered as one piece. Okay? As long as there's a space, that is a separate pieces. Okay, so there's 1, 2, 3, 4, 5. If there are 5 there, then what you get in here is 6. It's the number plus 1. Okay, you'll be 6 there. Right? And where does this all goes to? This one goes to the second input, which is this one. It's the argument string. Okay? The first one is the count. How many you have there? So here I got 1, 2, 3, 4, 5. 5 plus 1 is 6. Okay? So you appear 6 there. Why there's a 1 there? Actually that 1 is given. And this considered as 1, 2, 3, 4, 5, 6. So you got 6 there. Okay? And the argument, the first one will be this, the second one will be this, third, fourth, fifth, 6. Yeah? Now to demonstrate this, and show you the program. Okay, now if I do this, you see that this one will appear 6. And then this program here, I actually go through, if I look at the for loop, I equal to 0, I less than argument. That means you loop 6 times, because there's a plus there, right? You loop 6 times then. So every time you loop, you print out the I, start from 0, and then you print out also the string. Okay, the string, this string. You print out this. In each loop, you print 1 by 1. So you print this one, 0, 1, 2, 3, 4, 5. Okay? So let's try that one first. And not to go so many because otherwise you will miss what I'm telling you. So I'm going to do this one first. Just do this. Okay, the rest here I commented out. It's not important. Only the first posting. Okay, save this. Now I can start my terminal. Okay, let's try here I exec first. See where it is there. My one is already there. If not, then it's here. Okay, I don't need FEI exec to demonstrate this. I just need the program name. And in order to run the program, I need to go to folder first. x64 debug. Okay. Sorry, I did not assemble it. So we built. Everything nice. And I go back here, create, and I see my program there. Okay? And I type P6 exe. Well, I don't type exe is okay. Just P6. And you run, you should know that because it's a little file. I'm going to type in this 1, 12, 3, hello world. Okay, when I press enter, you run the program. Oh, sorry, I cannot type like that. I have to type like this. Put X here. No, I have to type here. I have to put.
它前面打了什么零？
Oh, sorry.
它前面打了什么零？
I don't need this X here. Okay. You just need to put dot backslash. Yeah. Then when you run, you have to put dot backslash. Okay. Dot backslash, and then the name of the file, program. Okay, and then I key in this, and you can see, just like what I mentioned to you, you print out. It's a bit small one there. So 0. The 0 is actually the name of the program that I run, p6.exe. And in front is also attached, which is not available here. We also attach the path to this program. So the path from the root, which is the C drive. So it shows you the path and the program name, which is the program name of this. And that is in string number 0. Okay? It's inside here argument 0. Okay, the first one. And the second one here, which is 1, which is not from 0, so the second one is 1, is actually this 1. Okay? And then 2 is this 12, 3 is this 3, hello world. Okay? Now, although this of course you know that is string, but this 1, 12, and 13, they are also string. They are not numbers. They are string of numbers. Okay? So it's an array of characters. ASCII character 1, ASCII character 1, and ASCII character 2 combined together. Right? Adjacent to one another. Now, if let's say I want to do something, I want to add 1 and 12. Bring these two numbers, and then display the sum and run a program like this. And okay, I cannot do like this, right? I cannot take argument US A1 because I know that is number 1 plus argument 2. Okay, basically I want to add this 1 and 12, so that is 13, right? And I want to put it into the result. Okay, this one will not work. You can see let's bring up. Okay, the sum is result. The sum is result. Okay, it will not work. When I compile, it will fail. Because why? Because this argument 1 is a string. This is also a string of characters. You know that string characters are not numbers, right? If I try to add this 1 and 12, it will generate compilation error. Okay, sorry, it will fail when I fail. It will complain. See that? It says cannot add 2 pointers. Actually, yeah, it's a pointer. These 2 pointers you cannot add and then put it into the result. Okay? It does not work that way. Okay? Because it's actually pointers or pointer to a string. So I need to convert first the ASCII characters or the string into actual number. And how do I do that? I do it by using this ASCII to integer. I don't know how to pronounce it. Right? Okay, ASCII to integer. That means I convert this string of ASCII into integer. Yeah? You can convert it into float as well. It's atop. Okay? ASCII to float. Then you convert it into floating point number. If let's say this is a floating point number. Okay? So you can choose, or you want to convert it into double, so then atop, which is ATOD, convert it into double. Okay? So I make sure that whatever here is numbers. Right? Okay, Okay, in our case here, now if I assemble it, okay, no complaint here, right? And I go back here and I run the program. And this time you add A1 and 12 and you print out the sum is 13. See, the sum is 13. See that? The sum is 13. But I know this is a bit small. I'm not sure how to. We can change. We will find out how to change the font. At the moment, you can try on your phone this program. Okay, and then you run using this dots backslash and then the name of your project, and then you give up the string. Okay. Now, if I want to add these three numbers, I can do so. I can change this. Okay, just add this with this. Yeah, and this one is 3, 1 to 3. Okay, so when I show one if you run the program, you get into this kind of situation. You want to run the program. You want to assemble the detail. Okay, once you create already, come back here, run it. Okay, so right now it's 16. Why is 16? Because 1 plus 12 plus 3 is 16, right? All these three numbers will be 16 because I have all those three numbers. Okay, there's a problem here. I have three numbers, but if I give only two numbers, how? You have a problem, right? For example, if I do like this. If I give only two numbers, okay, but my program actually expects three numbers. If I do this, it will be a problem. Okay, because why? It tried to access the third one, but third one is not there. Here the debugger is catching it. The debugger hasn't killed it yet. The operating system just killed it without telling you what is the problem. But the debugger is nice. Catch it, and then he'll tell you where the problem is. He also tell you there's a problem here relating to the pointer, so roughly you know there's something wrong. Okay, the reason is very clear. You only have two, but you request for the third one as well. Okay, so how do I overcome this? I overcome this by checking first. First, I check if the argument, okay, it's not 3. It's not 3. Then I exit. I print out error first. See errors. See error means I print out error. See out. Please give 3 numbers. Give error. Please give. Okay. And then I exit. Here first I check. Is the number 3? I mean the count is 3. There are 3 input parameters. Actually it's not 3, it's 3 plus 4, sorry. 3 plus 1, that means 4. Why 1? Because the name itself is considered as 1. Okay, so there are how many parameters there? There are 4, right? It should be 1, 2, 3, and then the third one, 4. 4, that's not 4. If it is not 4, please give 3 numbers, and then I exit, so that the user has to run the program again. Okay, it will not proceed, and then generate an error because I access non-existing numbers there. Okay, so if I do like this, let's build it. Once built already, go to the PowerShell, and I'll do this. You generate an error. See the error test. Please give number. But one number also the same. Please give the number. Okay, and then here I can. Now I try to put the number. Say I put 5, 6, 7. Now you'll be happy to add that. 5 plus 6 is 11. 11 plus 7 is 18. So that's correct. It's 18. So it's happy to print out. Just now I say please give a number. And now I give you 18. Now what if I apply more than 3 to 4, you generate error as well, right? Because of my if condition. My if condition says if exactly 4, not at 4, you generate error. So you give 5, you generate error. Okay, we want to remove the error because even though you give extra, okay, there's enough numbers there, you can do something like this. If it is not that, okay, if it is not, that means if it is less than this, then generate error. Okay, if it is 4 or more, you will not generate error. So if you do that, then this error will disappear. Like that. Like before, you will have to accept it, but it takes only 3. It takes only 3, even though you give 4, because of my condition. My condition state that if it is less than 4, generate an error. If it is bigger than 4 or equals to 4, don't generate an error or proceed on, because I can have that. Now this one depends on you. That condition is up to you to decide whether you want exactly that number or you want more than that number. Okay? Now take note, I do the reverse, the inverse of it. I don't check whether it is greater or equals to 4, but I do the inverse of it. That means inverse of greater or equal to 4 is less than 4, right? Because if it is less than 4, I can generate the error and do not proceed. Okay? Alright, so now with this explanation, I hope that you understand now. We come back to here to see how actually this program do this. Okay? Okay, so first thing is to check the argument. Is there 2 argument, exactly 2? If it is not 2, then we show you this error, just like what I did to you, showed you just now. Okay? And exit with mine was -1. Normally if we put -1, 1 is also fine. Okay, so and then you also tell you the program name, okay, usage, the program name, and then number of elements of the prompt. Okay, if you don't give exactly 2 input, exactly 1 input, then you generate this error. Okay, if you give exactly 1 input and then you convert it, see the avoider ASCII to integer, you convert it into integer. So basically, you just get the input from the user. The user has to key in 1 input, and that input is an integer number, and then it's converted. Now, because here I do not write a program to check also whether the number is really a number, because I can put hello there, right? If I put hello, then it actually satisfies the first condition, because if I put hello, they'll be exactly true, and then you get asked, but then you fail there, because hello cannot convert into integer, right? Okay, you can check that as well. There's another function, but I'm not going to discuss that. That function is to check whether that is a number, a floating point number, integer number, or whatever. Okay, you can check it. If it is not, then generate error also. Okay, but in this case, we assume that is a number, okay? Because we do not want to go into detail how to write that, because it will make this program a bit more. A little bit lengthier, so we assume that the user put in the number. Okay, this number is the number elements per prompt. It's basically telling the program what is this size here. You want it to be 2, 3, or 4. Okay? Now you specify the size, and then depending on the number of process, let's say the number of process is 4, and you also put in here 5 elements. 5 there, then 5 times 4 will be 20. So altogether, the data needs to be produced here by randomly is 20. Okay? Because each procedure will get 5. Okay, you get the 5 numbers to average. The 5 numbers to average. Okay? So that is what the program is trying to do. Okay, here we seed numbers, seed the random number generator. After seeding in already, we do get in, that's normal. And here, we need to find the rank. You should know how to find the rank. And here, you need to find the size. Okay? Because down below here, we're going to use the rank and the size. Okay, what about this code? This code here is to create array elements. The total size will be the number of elements of process times the number of processors. Remember I mentioned to you just now? If I give 5 here, the number of process is 4. 5 times 4 is 20. So 5 times 4, right? And then you pass that number 20 into create random number. Okay, the create random number is actually right on top here. Okay, so what it does is you take that array and then take this number, it will be 20 in all case, and then you go through one by one and it will create a memory first, create a memory of that size, and then you make sure that it's not null. That means it has enough memory. The second one, assert, is actually to check whether the memory is available. If the memory is available, it will not be null. If it is null, that means not enough memory. And then you generate error. Okay, that means generate error. That means you will not get past that line. But if let's say it is not null, you have enough memory, then you proceed on. Now in the for loop, you loop as many times as the number of elements, which is 20, and then you generate the random number. Sorry, the random number is this one. Okay, and then you divide by random max. What are you using to divide? I'm not very sure why you divide there. Oh, again, why? Okay, divide because we want it to be less than 1. Okay, because the random number generated is integer. Okay, and random max is actually the maximum number. So when you divide, it will be less than 1, right? Because that's the max number. Okay, so you generate random number which is double. As you can see, the double, right? So this random number is a array of doubles. Okay, once you generate enough already, 20 elements, and then you return the pointer or the address of this random number, because this name here is really the address of the array. Okay, you return back to the caller. So the caller will receive it here. It will receive it here. So that is done by process 0. Remember process 0 is the one that is going to handle this data, right? So it's going, first thing what it does is it put random number and put inside here. And then here we create also some memory for the process. Okay, so each process will create its own memory. We call it sub-random, which is this one. Okay, and the size this time is smaller. Okay, the size will be number of elements per process. If you put 5, here will be 5. Okay, why you need to multiply by double, size of double? Because malloc actually malloc the size of in bytes. This is number of elements, right? 5 times 8, because double is 8 bytes. So 5 times 8 is 40. Okay, so this is a pointer pointing to this memory. And then again, check whether the memory is available or not. If it is available, you proceed on. If not available, you stop here and generate an error. Okay, here what you need to do is you use scatter. And here I scatter, and you specify who is the root. The root will be P0. Okay, remember P0. You cannot put anyone because what? Because at the top here, 0 is the one that created the random number. So 0 has this. Okay, and here we need to be 0. The root needs to be 0. Okay? Okay, and then it will scatter to the communication channel, MPI world, MPI com world. So all these links will listen to the same channel. So it will scatter it into these processors. And once it's scattered already, each one of them will compute. So every of the process is going to compute the average. Okay. First, it takes the address of this, and then the number of elements per process. Okay, to compute the average, and the result will be stored inside this such average. Okay. So that is actually compute average here. Okay, the compute average will take in the array, which is the address of the buffer, and the number of elements, which is 5. So you do 5 times, and then you sum. And initially, the sum will be 0. So 0.f, that is actually a floating point. It looks very funny. Actually, what you should write is 0.0f. It is a proper way of writing. The f at the back there is to indicate that is a floating point number. Okay, actually you don't have to put that as well. You can actually remove it. Okay? You put 0.0, it knows that is a floating point. If you put like this, also can. 0 dot, it means there's a floating point number. Okay? And I think you can also put, I don't think you can put like this. This one will be okay? So you can put 0.0, it's fine. Do not need the f at the back there. And then you sum, and you return the sum. Okay, you return the sum. And that sum is divided by num element because you want to find the average, right? So you have to divide by num elements. Okay? So each one of the process will compute and they will receive here. Receive it here. Okay? Okay, so they are done already. So once everybody compute, that means you already reached this part here, already done this, already find the average. Now you want to gather. So how do you gather? You gather is done by rank 0 again. Okay, rank 0 is going to gather it. And first thing is he has to allocate this memory. Okay. Why do you need to allocate this memory? Because you need to collect the data, right? Gather the data. So when you collect that, it has to be placed inside it. Okay? So that's the reason why rank 0 have to do this. Allocate the memory again, and the size is both sides. Both sides, right? Because both sides is basically the number of processes. Okay? Then multiply by double. Each of the elements is double. Okay, so since there is sub average rate, and then you find out whether the memory is there, then proceed. If not, then we'll generate error. Okay? And here is a place where you have to get it. After you got the memory, then you get it. So MPI gather. Okay? MPI gather, then once you do the gather, you have to specify so the root is 0. Okay? And then the P0 is going to send there. P1 is going to send it there. P2 is going to send and then replace there. P3 is going to send and replace over. Okay? Now the number of elements here is for size of whole size. Okay, the number of elements. How about the number of elements here? The number of elements here is also whole size plus the prop size. Okay, so we need this information to pass to the scatter and also to the gather. Okay? So once that is done, now rank 0 again is going to compute the average. Okay, the average is going to be 4 this time, and the address is sub-average, the one that we allocated just now. So it is 4, right? Okay, once you get the average, you print out the average. Okay, print out, yes, print out that. Sorry, print out that, print out at the top of the screen. the second one, compute average, that is just to double check whether the one at the top is correct. Okay, so this few lines here is just to double check. Okay, this is done by process 0. Okay, process 0 is going to compute all. So now element prop plus the both sides, times the both sides, and that is the total number. Okay, and it's actually inside a random number, and then you compute the average, and that average is split. So you can double confirm to see whether it's correct. Okay, once that is done, you will clean up. You clean up it's done by rank 0 again. You clean up the rank number, the sub average, and all of them have to also free the sub random number. Okay, and then finally final. Right? So what you need to do here is only this. Find out how to put the whole rank, how to find the size, how to scatter, how to gather. Only 4. Okay? So that is your job. Okay. How to scatter. Let's have a look. Code here. Okay, here is a big, actually, this answer. Let's have a look at one of those. Scatter available. Okay, the first one is the sand buff. Okay? The sand buff is the buffer, this buffer. Okay. And then sand count. The sand count is how many? Yeah, how many in here? All right. And the data type you know is MPI double. And then the receive buffer is this buffer. This buffer. And receive count. The receive count will be the number of data per procedure. Per process. Okay, the one that the user key. Right? And the type is the same, MPI double again. And then the root is 0. MPI com is MPI com 0. Okay, so that is for the scatter. For the gather is more or less the same, I think. Okay, it's the same. Same bar, which is the size. That's why I pointed to here. And then the sand count is also the same thing. How many inside here? And then receive buffer will be this buffer, individual buffer. Each process will point to its own one. And the size here is process per, number of elements per process. In here. Okay, and the type will be MPI double. The root is 0. And the communication channel is MPI com 0. Okay, if you look at here, the answer is very there. Okay, so it's random number, which is the array. Number of element per process, MPI double, and it repeat. This one is repeating, but this one is not. This one is sub-rank number. This one is repeating from here. And then here is the type again, and then the root is 0, and then MPI combo. Here you can see that gather is slightly different. Why? Because here you got the size, right? The size is number of element per procedure. But when you take the average is only 1. Okay? When you take the average, it's only 1, right? So when you gather the time, it should be 1. That's why here it's 1. Okay? So sub average is 1, sub average is 1. Right? I think this one is not right. The gather here. You check and see. I think this one is not right. One of them should be 4. Oh no, yeah, it's correct, it's 1, 1. Because this gather is going to know how to actually move the data. So the data is only 1, so both of them should be 1, 1. Okay? 1 here, 1 here. Okay, take note also, this one is sub-average without the S. Okay, this is a scalar, that means it's individual variable, which is double. But this one is an array of double with the S at the back there. So there are 2 different variables there. Okay, so once you get the data already, you proceed on to add all of them together and then find the average. You clean out the average. Okay, so you should get something. These 2 numbers here must be the same. Okay? Now, doesn't need to be this exactly this number, yours will be different. But these 2 numbers on your screen should be the same. Okay? So you try that and run the program and let me know if you succeed. Okay? There are 4 things that you need to do. This one very simple. This one also very simple.
Finalize.
This one refer to the code that's given.
MPI
This one also look at the code that's given.
最上面
Here. First one and the second one. Okay.
MPI 是不是
And then run the
改
program.
什么东西？
Okay, when you run the program, you know all this.
Dia
Know that.
Lần thứ 6
Okay, my one will not compile, I believe. Or compile because I already changed this guy.
应该就可以
Because I put 0, 0, so it's happy to compile. Okay? If you don't put 0, 0, you see. Anyway, you don't need this. If you have done this part here,
มีพวกที่
then
3
this one is not needed. But because I did not do it, so I said, make my compile happy, I'm putting 0, 0.
我第一个洗澡时候评估了一个那种
Okay, right now,
要去那个考
and then
for
we'll see whether the answer is correct. This one is quite interesting. This one is P8. Oh, sorry, we haven't moved P8 yet, right? P7 first. P7 is equal to this last.
这两个地方不一样，
不一样。
一下就给一个，
你这个放，你这个是 input 的，你看过了？啊，你这个，应该是一样的。
该是一样，因为我没有改过，当然就
差不多。
我们学校有音乐课程，
不，我们这个才3。
是，
你按我可以吗？我看没有，是我圈来的。
that, you can actually proceed on to practical segment. Practical segment, the first part is working back the entry, and then the second part will be the cue down.
加这两个上去。
是，可是我加那里。
前面这样，
那个 clipboard 什么的，我都懂。
前面有 set it to 这样。
Can I ask why my mom cannot change the letter even though I also set for and whenever you sold them but I got this one double pieces.
You compile build solution. Fix that one first, and then you go back. It should be there.
Oh,
Okay, you have to build the solution first.
thank you.
At least one time.
其实这扣不上给你这个问题。
你是要去 debug 那一边是吗？
啊？
你是要去 directory debug 那边是吗？
就刚刚弄不到，他想要 build 一次就好了，然后 build 出了问题他就送，可是是口上给的。哦，两个已经没有。哦，不可以重复一样。这是 PQ 644要 comment 上来。哦，重复的，好神奇。 我帮人拍的。没有拍到。
没有那边太快了。
Guess what is my guess?
You follow the document. I have all the documents there. Just follow. I'm not sure why it doesn't work for you, but see what your plans are. And I want to see the rest as well. You actually get the correct answer. One person, you know, the correct answer. You got it?
在打。
不知道，我
点。
我
I think you've done something
我
wrong
直接
there.
看到是那个是这样打，可是我不确定。
是啊。他什么黑肉什么只打呢？
Do you get an answer? Yes, I think so. The two answers is correct. The two answers is the same. Then you think it's correct. Oh, that's good. You got it? Let's fix it. There are 4 parts. How about you? This is easy. You get it?
有点老师。后天被老师。
电脑是
开一下。啊，然后这个叫什么名字？一点是，然后打一个。然后再给他一个排蓝灯，然后就是错。
其实
Because if you are using print app, I see a number of you use print app, right? You have to include this. Otherwise you'll complain. At the top there you have to include, or in my case, I don't include. Okay. Do you have IOStream? If you don't have IOStream, then you have to include this. If you don't change the CR and all that, you have to include these 2 line items, otherwise the complaint Okay, you have to include these two. The first two that I put down there, I commented out because I don't use this. In your case, you might need to include. Okay? If you use spring app, you might need to include that too. The first one is STDIO. The second one is STD link, standard library. Okay, you need to do that. In my case, because I changed my code, I don't use CR. So I don't use spring app, I use CR. That's why I don't need it.
这里放。
已经靠来的，是。Because mandatory is P6.
Scroll, I don't see what you cut. P6, no, slash is this direction. You have to follow this direction. Backslash. In Linux is /. In Windows is backslash.
So like this.
Enter. It's not recognized. The program is not there. Build. Build. You got error. You have to fix this one first. If you don't fix it, you won't have it.
Oh.
Maybe it's missing. What is missing? The closing brace missing. You have to check how many braces that you have. I think this one you don't have. Missing the. Not sure. You have to check.
I check.
You have missing braces.
Take this.
Got it?
记得。可是好像是那个。
Running.
你对你 L 样子。
啊？我操！
塞。
不是，他还是讲 integer 是容易。哎呦，这个。
有那个，只有 copy
好，我再 copy。
我就是 ID。
是吗？
If you use size and rank, then all needs to be changed, rank and size. You cannot just copy and paste. The variable name is different.
没问题。 哦，可以了。OK。不是名字，打几个对的。可是我打这些的话，它 error。OK， 3个码。8、7个可以。忘掉了。
这是不可能。
点这个是它的那个 score。
72万就是
20，
这样子。
拉
古早的
有问题吗？
F，古早的
那现在 comment
你这个 P6Q4 可能这样，
是没有，
可是还是我会做很多的。
有可能应该会很恐怖的，它在它上面。
对啊，会有空调吗？
P6Q4。
哦，这个很多
啊。
按吧。
Ctrl Shift 加 Source。3个键。
这个是好的意思是不是？
你就可以让那个 power 下。
到 backslash
credit card，然后打3个号码，空格
不是老师要是这个吗？
它是4嘛，我们放3。
好像要这个是吗？
以为是这个。
这个是之前的好吗？我不确定。
确实是做好。只要会问老师方面看。改一下。
我不知道，我不好从哪里拿。
有空。哦，那个口音。是烂integer。它integer是这样长的。
做错了，integer 没这样长。 没有吗？它这个是 main，然后我们改成 scatter gather 的。
哦，这怎么能烂一点
？Both sides and right. Because you use here, right?
Moral scatter ALGC
Oh, you got this one. It's not okay, you can actually do it. This one is my
Control Shift 很难。旁边的话 Control Shift。
哦，Shift 加 Reset， 这样，Control Shift 加，这么还是不错的，完美六，真是烦，300。
Okay, so this one is the this one for the
这个是真的一万吗？
啊？
这个是让你软的。
一样哦，一样，那个这边下面。
已经有问题了。哦，你这个上面一样。
是的，334的一起。
应该是这样打，不用跟它的 example 不一样，只要两个是一样的就可以。哦，对。哦，自己开多可以低就可以。
啊，自己开多。
你有return东西？
return，就是放它名字嘛，就那个 schedule 下去。
不用前面不用 declare 是不是？
啊，就是。
ARGC。
Okay. Alright. No, right?
这样子吗？你就打到 slash 字，
然后一个号码。
Okay, you put 1,000, that means you got, it has 1,000 to average. Each one of them will be 1,000. So you got 4,000. So 1,000, 1,000, 1,000, 1,000. Okay, if you put 1 million, Then with 1 million, 1 million, 1 million, 1 million. And P0 has 4 million. 4 million elements inside there. You can try. To run the program, just in case, because I see some of you do not know how to run the program. You run the program with this MPI, Z, and let's say you want 4, put 4 there, and then your program name, okay, and then the number, let's say I want 1 million, then I put that is 1 million. 1 million, okay, press enter. And of course my one does not do anything here because my one error because I did not write the program, right? So if you put 1 million, then you create 4 million here because there are 4 processors. 4 times 1 million, 4 million. And then you scatter 1 million, 1 million, 1 million, 1 million. Okay? And then you average all the 1 million elements into an average. Okay? And P0 is going to gather all of them, but there will be 4. After you take the average, then you find the average. If you put 1 million, it will be a bit slower. Okay? It takes time to process it. Okay, so everybody follow? No? Anybody has problem still?
这有没有是对的？
对的吧？
Anybody has problem? I see this look good. How are you? This how you okay, missing. Look at the no, because I did not write the program. I did not fill that right. Okay. You have to fill
Physics.
哦，你 present 也不是用 slide present， 不是有
哦，可以这样就秀给他看了，然后给他看你的 FIP 中的那个东西，可是要准备slide，
要准备 slide。
看你老师，我老师要求是，我就听到风就讲你们要不多带。
initialize, and then you because you have to do it. So yeah. This. Once you have done that, okay, if you see there's a lot of error, most of the time is the first error that is causing all the cascaded error. Whereas sometimes you see like 1,000 errors or 100 or more errors. Actually, the error is only 2 errors. The first 2 errors. Okay? So whenever you see error, you always scroll up, look at the first few errors. If you fix that few errors, normally it will clear up the rest. Because the rest of the errors are normally repeating. Okay? Repeating errors. Okay, the next exercise, at what time we finish? 2 o'clock.
No, 1:30.
1 to 2. The next exercise is P7. I think this exercise, maybe we go through it. This few questions is very simple. Maybe this one is a bit more challenging, question 2. So we don't do question 2 yet. Do question 1 first. Okay, previously you saw that the private variables, this one is OMP, nothing to do with MPI. We go back to OMP again. Okay, this is Article 7. Previously you saw that the private variables are completely separate from any variables by the name in the surrounding scope. Okay? So that means you create the private variable which are separated. Okay? However, there are 2 cases where you want here the storage association between private variables and the global counterpart. That means we do not want a separate private. What it means is this. Let's say, for example, you have a global with the same name. Let's call it value 1. Value, integer. So in global, and then you got a private one. The private one is in the this scope here. Yeah? So even though the name is the same, but this is global, this is private. Okay? It's 2 separate copies. Okay, so it's asking, it's stating that this and this is 2 different copies, even though they share the same name. But in some situations, we want this and this to be the same one. We do not want this to be private. We want this to be this. Okay? So how do we do it? Okay, we want some association. That means it's the same. First of all, private variables are created with undefined value. Okay, you can force their initialization.
Future improvement.
Okay? For example, in this case here, let's look at maybe the example is easier. If I put pragma,
有几个人做到？
OMP parallel. Okay? And then I put the opening brace here, closing brace here, right? And let's say I got the integer t here. Okay? And then integer t here. So my question here, is this the same t or different t? Is it the same t or different t? Just now I already mentioned to you. Huh? Different. This is private, this global. Okay. If I have 4 processes running, how many t I have here? 1. How many t I have here? 4. That is right. And this 4 is 4 different t, even though they are the same name. Each t belongs to 1 process. And that t is not the same as this t. Okay? Now the problem is that sometimes I want this value, or I want to share this t. Okay? How do I do it? Okay, you cannot do something like this. T equals to t, assuming that this t comes from the outside t. Maybe this t has a value 2. I want this 2 to be inside here. Okay? So you got a problem here where this t, you cannot do something like this because this t is actually the same t as this. Okay? And this one will fail. So if you want this value to be inside here and also is shared, then you do like this. Like what they show here. First private. Okay? First private means when it comes into here, that p is actually this value 2. Okay? Now this t, is it the same t as this t? If I put first private, is this t the same t as this? No, it's still not the same t. This is global t, this is the private t. But that 2 is in the t. It's the same as I'm taking this 2 here into the private t. Okay? Alright? So, this, okay, first of all, the private variables are created with the undefined value. We can force their initialization. And this is t here is going to be 2. Okay, the variable t behaves like a private variable. Okay, so this is a private variable, except that it is initialized to the outside value, which is this 2 here. Okay? Okay, secondly, you may want a private value to be preserved to the environment. Now we are talking about last private. Okay, last private is this. When I do the computation already, right? Some computation. And I want to write this value back into the global t. Okay, that private t is separated from this global t, but I want to write the last value into here. That one is last private. So first private means on entering into this OMP parallel, the global value is initialized to the private t first before you run the program. Last private means before you exit, okay, before you exit, you put the value back into the global value. That means when you compute here, okay, the private temp here is written back into this original one. Okay, only the last one is written. While it is computing here, it is not written. When you get out from this pragma, then only it's written. You get it? Okay? Previously, we don't have this kind of chance to do it. Okay? Because when you create inside there, you cannot pass the value in easily. Alright? So that was a problem earlier on. And also, when you get out, you cannot update the outside. Okay? You cannot update outside easily. So if we use first private, last private, then we can perform this for you. Okay? Now we will try this example here. This example shows to us how it is used and why you need to use it. Because if you don't use it, there's no way that you can solve it. Okay, you need this first private and last private to help you do. Okay? If you don't use this first private, last private, you use the ordinary private variable, you're not going to solve it. Okay, this is a bit lengthy. It's also confusing because the code is very lengthy. Right? Actually, it's not really very lengthy. The computation here is very complex. Okay, so what we need is to copy this and paste it. I have only 9 minutes to do that. Okay, the correct answer is given at the top here. This is the correct answer. Maybe I can copy it over here. Right? And this is a different exercise we're going to do. Okay, I'm going to T7. Good, now T7. And then paste it here. Okay, we don't use MPI anymore. This one is OMP. And okay, we can run the program. but you'll get the wrong answer because the correct answer is this. Alright? So what you need to do is just change here. Okay? Change here so that you get the first private and last private. The be in here. I think it's not there, it's somewhere else. Let's have a look.
做成当
Okay, there's an instruction here. Identify the private variable in the current region. Okay, pass the correct argument in the test point function. Okay, there's another thing that you need to do, identify atomic function. Okay, this atomic function because there's a race condition. So you have to use this atomic function so that you compute the correct answer. Okay, so you have to identify which is the prime variable first, and then which one that you need to first update it. First private, and then which one is last private. Okay. Okay, if you want to know more about boundary book set, you can actually go to here. Just to try to understand what boundary book is all about. It's actually practical. What algebra is interesting is if you zoom in, then you see the pattern repeat. Okay? When you zoom in, you see this pattern repeat. You can see that this pattern here is actually this, and it's actually this. Okay? As you go in further and further, and it will never end. As you zoom in, never ending zooming, you see this factor keep on appearing. Okay? So that is multiple set. Okay, I think I have enough time to take this first.
Alika.
Chai Hong, Lim Yong, Xu Zizhen, Chia Zhenyi, Benjamin, Gagayson, Dashini, Uweli, Jackson, Lao Yongjing, Yongjing Hoyer, Li Shenhai, Liu Weizhen, Ling Jiayi, Lin Weihan, Tan Chunho, Hoi Shun, Han Yu-hun, Samyukta, Tan Chong-han, Tan Shen-ji, Tan Xiu-yan,
很高，
Tan Xiu-yan,
反射是吗？
Tan Wen-tiao,
应该是跟你说。
Wang Xin-ji, Li Jianyue, Lao Yongjing here. Okay, so this is now the book. Okay, you refer to this in order to understand what this mechanism is. I can't actually explain what it is. There is exercise for the first part.
Let me see these people.
Okay, you can go now. But please save first your project, so next week you don't have to do it again. Save it somewhere. Remember to turn on the OMP, that means you have to go to the project here of this. Language, and then turn on this place. Yes. Okay, let's save it. Okay, the answer here is wrong. Okay, fix it in order to get this answer. So save this and then you can leave it on. Before you save, actually you should clean first. Clean your work.
PM 的quality 我已经改了，然后你看它可以那样子写。
这样挺好看。我觉得明天去了啊，有问题，明天晚上改完，星期六我们就要别的上。
after the production class posted. So keep remind me because I forget. Okay. If you don't see, remind me because I will print them out.